AG 104 Lesson 2 Learning Activity Instructions. Copy and answer the following problem sets. Problem 1.1. How many electrons does each of the following elements have in its outermost electron shell? Namely, potassium, calcium, and aluminum. So first, the potassium. Potassium has an atomic number of 19. Here, atomic number of 19, which means there are 19 electrons to plot in the orbital rings using the Bohr model of an atom. First ring is 2 electron holds. The second ring can hold 8 electrons. The third ring can hold 8 electrons. Then lastly, the fourth ring can hold 1 electron. So, because potassium has 19 of atomic number, here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. Calcium. Calcium has an atomic number of 20, which means there are 20 electrons plot in the orbital rings using the Bohr model of an atom. First, the first ring can hold 2 electrons. The second ring can hold 8 electrons. The third ring can hold 8 electrons, and calcium can hold 2 electrons, because the atomic number of calcium is 20. So let's count this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So, the valence of electrons, or the outermost electron, is 2. Here, 1, 2. The aluminum. Aluminum has an atomic number of 13. Here, 13. Atomic number 13. Then, which means there are 13 electrons plot in the orbital rings using the Bohr model of an atom. First ring can hold 2 electrons. Second ring can hold 8 electrons. And the last thing is 3 electrons. So, the valence of electron, or the outermost electron, is 3. Why? This 1, 2, 3. And also, there are 13 number. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Problem 1.2. Give the ground state electron configuration of the following elements. First, boron. The answer is 1s2, 2s2, 2p1. Because the Atomic number of boron is 5. So, 2 plus 2 equals 4 plus 1 is equal to 5. In phosphorus, the answer is 1 is 2, 2 is 2, 2p6, 3 is 2, and 3p3. Phosphorus has an atomic number of 15. So, 2 plus 2, 4, plus 6, 10, 10 plus 2, 12, 12 plus 3 is equal to 15. In oxygen, oxygen has an atomic number of 8, and the ground state electron configuration of oxygen is 1 is 2, 2 is 2, and 2p4. Two plus 2 equals 4, plus 4 is equal to 8. As you can see here, 8 atomic number of oxygen. In argon, the answer is 1 is 2, 2 is 2, 2p6, 3 is 2, 3p6. Thus, argon has an atomic number of 18. So, 2 plus 2 is 4, plus 6, 10, 10 plus 2, 12, 12 plus 6 is equal to 18. 1.6. Write both electron dot and line band structures for the following molecules showing all non-bonded electrons. CHCl3 chloroform, CH here, and the 3Cl or chlorine. 1, 2, 3. There are 26 valence electrons in these elements. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, and 5, 26. Letter B, H2S or hydrogen sulfate. S and the 2 hydrogen, 1, 2. The valence electron of this element is 8. So 1, 2, 3, 4, 5, 6, 7, 8. Letter C, CH3NH2 or methylamine. C, the 3 hydrogen, 1, 2, 3, and N, the 2 hydrogen also, 1, 2. So the valence of electron in this element is 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
Now let's proceed to 1.7. Why can't an organic molecule have the formula C2H7 or methane? My answer is carbon makes 4 bonds and hydrogen makes 1 bond. Carbon and hydrogen cannot exceed these numbers of bonds because their valence shells can fit only 8 and 2 electrons respectively. Therefore, an organic molecule cannot have the formula because that would require a carbon atom to have more than 4 bonds and hydrogen atom to have more than 1 bond. 1.16. Which element in each of the following pairs is more electronegative? So, letter A, lithium or hydrogen. So, lithium has a electronegativity of 1.0. 1.0 and hydrogen is 2.1. That means hydrogen is more electronegative. Letter B, beryllium or bromine. So beryllium has 1.5 electronegativity and bromine has 2.8. So that means bromine is more electronegative. Letter C, chlorine or iodine. So chlorine has 2.8 electronegativity and iodine has 2.5. That means chlorine is more electronegative. 1.17. Use the partially positive and partially negative convention to indicate the direction of expected polarity of each of the bonds shown. So we will only get the electronegativity of carbon and nitrogen. So carbon has letter B. Carbon has 2.5 electronegativity and nitrogen has 3.0. So nitrogen is more electronegative. That means carbon is partially positive and nitrogen is partially negative. Letter C, we will get the electronegativities of nitrogen and hydrogen. So nitrogen has 3.0 electronegativity and hydrogen has 2.1. So nitrogen is more electronegative. Hydrogen is partially positive and nitrogen is partially negative. Letter D, carbon and sulfur. So carbon has 2.5 electronegativity and sulfur is 2.4. So that means carbon is more electronegative. And this means carbon is partially negative and sulfur is partially positive. Letter E, carbon and magnesium. So carbon has 2.5 electronegativity and magnesium has 1.2. So carbon is more electronegative. That means carbon is partially negative and magnesium is partially positive. Now letter F, carbon and fluorine. So carbon has 2.5 electronegativity and fluorine has 4.1. So fluorine is more electronegative. That means carbon is partially positive and fluorine is partially negative. 1.18. Order the bonds in the following compounds according to their increasing ionic character. Tetrachloromethane, magnesium chloride, titanium tetrachloride, and dichlorine monoxide. So in order to get the ionic character, we will get the electronegativity differences. First is carbon and chlorine. So carbon has 2.5 electronegativity and chlorine has 3.0. So the difference between carbon and chlorine is 0.5. For magnesium and chlorine, magnesium has 1.2 electronegativity and chlorine has 3.0. So 3.0 minus 1.2 is equal to 1.8. Titanium and chlorine. So titanium has 1.5 electronegativity and chlorine has 3.0. So 3.0 minus 1.5 is equal to 1.5. For chlorine and oxygen, oxygen has 3.5 electronegativity and chlorine has 3.0. So 3.5 minus 3.0 is 0.5. So My answer according to their increasing ionic character is first the tetrachloromethane, followed by dichlorine monoxide, then titanium tetrachloride, and the last one is magnesium chloride. That's all. Thank you.